Good day, ladies and gentlemen. Welcome to Ekas Mathematics. This is actually my first video, so make sure to like, subscribe, comment, share it with your friends, recommend it to anyone who you know that is actually in need of mathematics help, so that they can pass their matrix or whatever that they're doing. So on this first video, I'll be taking you guys through number patterns. Number patterns. So what are number patterns? Basically, number patterns are a list. So basically, a list of numbers in a particular order is called a number pattern or a number sequence. A number pattern or a number sequence. So there should at least be three minimum numbers in the list to work out. For an example, if I have 2, 4, and then I don't have the third, I don't have a third term here. Many different patterns are possible. For instance, I could have 2, 4, 8, which is just basically which you just multiply each number by 2. Or you could have 2, 4, 2, 4 again, which is just a repeating pattern. So a single number in a pattern is called a term. So this is term 1, this is term 2, this is term 3. You subscript with the position, so your n is the position of your term. So term 1, term 1. Term 2, T, and then your subscript 2. Term 3, T, then your subscript 3. For instance, T9 will be your 9th term in the sequence. Okay, so let's make an example of a sequence. Let's look at a sequence. What is a general or a typical example of a sequence will be 3, 8, 13. So 3, 8, 13. So this is your first term. This is T1, this is T2, and then this is T3. So you can tell here that from the first term you add 5 to get the second term. Then from the second term you also add 5 to get the third term. So hence one is able to predict what term 4 will be, because then term 4 will be the term 3 plus 5, and then term 3 is 13 plus 5, then that will give you 18. Another typical example will be 3, 15, 75. So you can tell again that you multiply the previous number by 5. So your T4 here will be T3 times 5, which is 75 times 5, which will then give you 325. So from here, we now know how a sequence looks like, a typical sequence looks like, and how you can actually predict again the terms that are not given in the first 3 terms. So there are different types of sequences. There is an arithmetic sequence. There is a quadratic sequence, and then there is a geometric sequence. But in this video, in this video, we're just going to focus on the arithmetic sequence first, and then I'll upload another video where I'll be explaining further with regards to the quadratic sequence as well as the geometric sequence. So the arithmetic sequence, basically the arithmetic sequence is basically is a sequence where the common difference which we notate by letter D, small letter D, a common difference between the two consecutive terms is constant. An arithmetic sequence is a sequence where the common distance D between two consecutive terms is constant. So for instance, that means T2 minus T1, which is the difference between two consecutive terms, would be equal to T3 minus T2, which will be equal to T4 minus T3, and so on. That's the common difference. It is constant throughout the whole sequence. So let's make an example again. Another typical example will be 5, 9, 13, and 17. 5, 9, 13, and 17. And then the first question would say, determine the common difference. Determine the common difference. We've already explained that the common difference, you get the common difference from the two consecutive terms. So T2 minus T1, which will also equal to T, which is 9 minus 5. This is T1, T2, T3, T4. So it's 9 minus 5, which is equal to 4. We could have also used, alternatively, we could have also used T3 minus T2, which is going to be 13 minus 9, which is also equal to 4. Also, we could have used T4 minus T3, which is 17 minus 13, and that gives us 4. Then the following question again will be, determine the next two terms. Determine the next two terms. So we know that the difference between T5 minus T4 is equal to 5 because it's constant throughout. Therefore, T5 is equal to, we transpose T4 to the other side, T4 plus 5, which is going to be 17 plus 5, and that is 21. Again, same with T6, it will be T5 plus 5, which is 21 plus 5, and that is 26. So for now, that's all we know with arithmetic sequence. We know that the difference between the two consecutive terms is constant throughout the whole sequence. The difference between two consecutive terms is constant. That's far we know that. So if now okay, T1, T2, T3, and T4. So if now that we know that the difference throughout is constant, and then we say let's just be typical and say T1 is equal to A. Let us label our first term as A. So T1 is equal to A, then the difference D, the common difference throughout, in the we've already decided to notate it as D. Then the general term. For an arithmetic sequence is n is equal to, by the way, again, note that this n stands for position. But here we are looking for the general term. We are looking for an equation that is going to define even terms that are not included in example. For instance, we are looking for an equation where we can find the value what say for instance what position will be say okay, let's just go back here. Say for instance, if I was given 26, what position would be 26 in our sequence? So we can just use a general term or a general formula to describe all of that. So it will be a plus n minus 1 times d, which is our difference. This is a general term for arithmetic sequence. This is our general term. Tn is equal to a plus n minus 1 times d. And then from here, everything is simple. We can calculate anything from here. We can calculate n, we can calculate Tn, we can calculate a, which is our first term, or we can calculate d, which is our difference. So note that our general term has four different variables. It is Tn, it is a, it is n. So Tn is the value, a is the first term, n is the position, then d is your difference. So let's go through a simple example, and then let's see how we can apply all of this. So given the sequence 4, 10, and 16, then the first question, determine the formula for the nth term. Determine the formula, so you're looking for the Tn. Determine the formula for the nth term of the sequence, the Tn. So from here we can deduce what a is. A is our first term, 4, and then the difference, 10 minus 4, that's 6. 16 minus 10, that's 6. So difference here will be 6. So you already know what the value of a is and the value of d is. So let's just substitute this from our general term. So Tn will be a 4 plus n minus 1 into our difference is 6. So we have 4 plus 6n minus 6. Therefore, our general term will be 6n minus 2. This is our general term. This is the formula for the nth term of the sequence. And then the following question will be calculate the fifth term. Calculate the fifth term. What will be the fifth term of this sequence? We are only given 3 first terms of the sequence. Now we want to know what is the fifth term of the sequence. But you already have the general formula of the sequence. So we just substitute 50 in the position. So T50 will be, when there is n, we substitute it with 50. Please take note, this is very important. This is extremely important. Where there is n, we substitute it with 50 because we are looking for the value of Tn at the fifth position. So 6, when there is n, I substitute with 50 minus 2. So this is 300 minus 2. This is 298. Please confirm this, but yeah, 60 times 6 times 50 There's 300 minus 2, and then there's 298. Last but not least, which of the term, so we're looking for Tn now, which of the term, which position in the sequence would give us Tn is equal to 310? Which term of the sequence is equal to 310? So we are looking for the n now. We are looking for the position where our Tn is equal to 310. Again, it's no brainer. So Tn is equal to 6n minus 2, which is equal to 310. And then we can solve for n. So 6n is equal to, we transpose 2 to the other side, 312. Divide by 6, divide by 6. Your n is equal to 52. So it's very simple, it's straightforward. There won't be any trick here. It's just arithmetic is a very basic and the most simplest types of number patterns or number sequences. But let's just do one more. Let's just do one more, which is a little bit complicated. Not so much, but let us do one that's it's just a little bit different from the ones that we've been doing so far. Example 3. Given the arithmetic sequence 1 minus p, 2p minus 3, p plus 5. So we are being told that this is an arithmetic sequence. Determine the first question is determine the value of p. Please pause this video and see if you can try and attempt to do this on your own. Determine the value of p. Just pause this video and then try and attempt it yourself. Okay, okay, that's fine. So we are already told from the statement above that this is an arithmetic sequence. So what do we know about arithmetic sequence? We know that the difference is constant. The common difference between two consecutive terms is constant. So the difference here will be equal to the difference here. So what is the difference here? 2p minus 3 minus, please mind the brackets. They are very important. Because one would just attempt to do this by just putting this as it is, forgetting that this is actually one term. This is T1, this is T2, this is T3. This is one term. This is one term as well as this one. Minus 1 minus p. Then the difference here will be p plus 5 minus 2p minus 3. We know that the difference here is common, so this is equal to this one. So let's just write it in a proper manner. So we have 2p minus 3 minus 1 minus p is equal to p plus 5 minus 2p minus 3. So 2p minus 3, that's just 2p minus 3. Minus 1 times 1, positive 1, that's minus 1. Minus 1 times negative p, that's positive p, is equal to p plus 5. And then minus 1 times positive 2p, that's minus 2p. Minus 1 times minus 3, that's positive 3. Then we group all the like terms. 2p plus p, that's 3p, minus 3 minus 1, that's minus 4, is equal to p minus 2p, that's minus p. 5 plus 3, that's 8. So we transpose p to this other side and then 4 to this other side. So we have 4p is equal to 4, it becomes positive. So 8 plus 4, that's 12. Therefore, our P is equal to 3. 4 divide by 4 throughout. So 12 divided by 3, that's 12 divided by 4, that's 3. So our value of P is equal to 3. And then the second question will be, then give the first 3 terms of the sequence. So wherever there is P, we substitute it with 3. So it's 1 minus 3, which gives us minus 2. 2P, so it's going to be 2P, 2 times 3, that's 6, minus 3, that's 3. So 6 minus 3, that's 3. Then our third term will be P, which is equal to 3, plus 5, that's 8. So let's just verify whether the value of P gives us an arithmetic sequence. So 3 minus 2, 3 minus negative 2, that's 5, positive 5. 8 minus 3, that's positive 5. So our value of P is indeed correct. And then from here, you can go on to get the nth term of the sequence. You can go on to get the value of which term of the sequence is equal to this number by just getting your general term. So it's very important to move from here. Also, the logic here was just, you know that the difference is common, hence you can just equate this to this and then get the value of P. It was nice being with you. Hopefully we'll see each other on the next video where I'll upload the quadratic sequence and then geometric sequence, and then start on series. And then from there onwards, what I'll do is I'll put up a list of question papers from starting from 2018 up until 2021. All the question papers with arithmetic, quadratic, geometric, just to make sure that we cover up everything. It was nice being with you. Enjoy, guys.